Hey guys, in this video, we are going to have a look at the workarounds of Jupyter Notebook as well as certain Python basics. So we need to familiarize ourselves with the environment Jupyter Notebook sets for us. So this is a notebook that you can download from the resources section of this video. And in order to run a cell, we basically use Shift Enter. We double click in order to edit a markdown cell. So there are two kinds of cells as we can see from this drop down. There is a raw cell, there is a code cell, or there is a markdown. Majority of the times you might be working with notebooks that have been pre-baked. So just double click in order to edit it and shift enter in order to apply the changes. As you can see, in order to create a content with a view that has a code font, we use double double stars. All right. And in order to create a magnified heading, sort of like an H1 tag from HTML, if you might be familiar with that, we use a bunch of pound signs, right? And in order to uh, edit, we can also use enter. So here I can edit my markdown cell. Markdown cells are basically how to do a tutorial sort of thing or a description of what the following cells are going to be about. And as we can see, Jupyter Notebook provides us with a number of options. Within file, we have an option to open a console, open a new notebook, text file, a Python file. We can save notebook as to a particular location, or we can download this in the form of IPYNB or IPython notebook format. We can save and export our notebook in a variety of formats, and we can also shut down. Just make sure that while we are running Jupyter Notebook, our terminal should not be closed because this is an instance that needs to be running. So this terminal does not need to be disturbed. And the plus sign is used to create a new cell. By default, it defaults to code cell. We can also change it from this drop down. In order to delete a cell, there is an option uh, to delete, or we can also use D button, as is hinted uh, by this icon, right? And within kernel, we can either interrupt kernel or we can basically interrupt the execution of a running Python notebook. We can restart kernel. So sometimes when a data science notebook exhausts a lot of our resources, a lot of our system resources, we can just restart the kernel to restart the notebook again. And we can also attempt to clear the outputs that the cells might have generated. We can also restart kernel and run up to particular cells, or we can simply restart and run all the cells. Or we can reconnect to kernel, which is sometimes we do when our notebook kind of hangs, right? And yes, we can download as well. These are some references that you might refer to in order to get to know about more of the details. We are going to head over to Python objects, basic types, and variables. So Python is an interpreted language and it is a dynamically typed language. So unlike your traditional languages that are compiled like C, C++, or Java, where you have to explicitly uh, mention that whether this variable is of an int type or a float type, or whether it is a string or whether it is a Boolean variable. In Python, it is dynamic in nature. So basically, the interpreter interprets what kind of variable is present based on our assignment of the value. An integer variable will typically have an integer value. If we need to define an integer variable in the form of a float variable, we can do 10.0, right? Similarly, for float variables, And similarly for string variables, we can use single quotes or we can use double quotes. We can also use triple quotes or triple double quotes, which comes in handy in case a string has single quotes within the string definition. Then there are Boolean variables which simply have the assignment of true or false. We have a none type, which is a special type representing the absence of a value, or we want the flexibility to define just a empty container that we can change on the go. We can just define it as a equals to none. That defines a none type. In Python, a variable is a name that we specify in our code that maps to a particular object instance of values. There are certain constraints when attempting to define variable names, such that our variable names can only start with letters, underscores, or numbers, right? And variable names need to start with a letter or an underscore. We cannot define a variable name as 123 var, for example. It needs to start with a letter or underscore. Underscore can be in between as well. Then moving on to certain basic operators that any programming language has. We have arithmetic operators, plus for addition, minus for subtraction, star for multiplication, slash for division, a double star for exponent. Then we have assignment operators. Equals is used to assign a value. For example, a equals to 3, or num1 equals to 10, or num2 equals to minus 3. Then we have plus equals. Plus equals is equivalent to uh, num1 plus equals to 1 in order to increment the variable by 1, which translates to, we can use hash in order to define a comment. Comment is basically uh, comment is basically a description of what our code is doing that is usually preceding the line of code in interest. So num1 would be equal to num1 plus 1, right? So this is shortened to this, plus equals to, right? Then we have minus equals to, which is subtract and reassign. It is similar in nature, like num1 equals to num1 minus 1. Similarly, we have star equals to, multiply and reassign. Note that we have double equals to for comparison operator. For instance, I want to check whether num1 equals to 10 or not. I use shift enter for execute, and once I do so, I get whether the value is true or not. Oh, I need to actually print the result of num1 equals 10 or not, and it says true. Here, these are just assignments, so that doesn't generate any output in the output section. Then we have less than for less than, and this exclamation mark followed by equal to for not equal to, lesser than equal to, greater than, or greater than equal to. When multiple operators are used in an expression, we have something called as operator precedence. So operator precedence defines the order in which the operations would typically take place, right? The topmost priority goes to the expression. Expression within parenthesis is evaluated first, and then exponent is evaluated or exponent operation is carried out, followed by multiplication and division. So P stands for parenthesis, E for exponent, M for multiplication and division, and A for subtraction, A for addition, and S for subtraction. This is followed by any other comparisons that we might have defined. Double equals to for checking whether LHS is equal to RHS, true or false. It generates all of these comparison operators. They return as output Boolean variables. Boolean variables meaning whether this expression evaluates to true or not. So this is just addition. Num1 is defined as 10, num2 is defined as -3, and this indeed generates 7. Then num2 and num3 are defined. We carry out subtraction, then multiplication, division, exponent. So num5, basically 7 cube, 7 or 7 raised to the power 3. That gives us 343. We can increment an existing variable. So num7, which is defined as 11.11, we are incrementing it by 4, which gives us the output 15.11. Or we can decrement an existing variable. That is, we want to decrement the value within num6, the value that num6 is holding, which is a value of 3, and we want to decrement it by 2. Or we can multiply and reassign, like the value of num3 is 7.41, and we want to multiply it by 5. That gives us 37.05. We can assign the value of an expression to a variable as well. Like I want to define a num8, a new variable, as the, uh, you know, this expression. So again, in this expression, the PEMDAS rule will follow. That is, the multiplication of num2 and num3 will proceed first, followed by addition, right? Then in this case also, first of all, this expression will be evaluated. We can also include this in parentheses for more readability or for more clarity of expression. But nonetheless, this expression will be evaluated first, and then we get to check whether this is equal to num5 or not. Similarly, we can check whether a couple of expressions are equal or not. Like we are checking whether two numbers are equal or not. Then we can check whether this variable is lesser than num5 is lesser than num6. We can similarly have cascaded operators. Cascading means having multiple expressions one after the other in the same line, that whether 5 is lesser than 3 is lesser than 1. Then we can also evaluate whether this expression holds true or not. So I leave this as an understanding exercise for you as to whether you can evaluate whether this expression holds true or not. Again, remember the PEMDAS operator precedence or the order of operations. Then we can assign some strings to certain variables. This is a simple string 1 where we have used single quotes, and this is an example where we have used double quotes. We can also use addition on top of strings, which basically concatenates one string with the other. Like an example of using the plus operator, the result will be that. Similarly, we can use multiplication. What multiplication will do is that it will append whatever value is contained within the simple string to 4 times. Then we can also uh, verify that whether the string was modified in the first place or not. So we can see that simply by carrying out this operation, this does not alter the original string, right? And similarly, we can evaluate whether two expressions are equal or are they identical or not. We can also use a literal string. This is a string literal basically, as in we have a predefined value against which we are checking for equality. Then we can add and reassign. We can append this string at the end of the string, and we can add and reassign. Similarly, we can multiply and reassign. And once we do so, we are altering the string, right? Then we move on to basic containers in the next video. Thank you for watching.